Hello, everybody. I'm Damon Cortese with AWS, and here today to talk to you about building a data lake with AWS. So we'll talk about some of the different managed services you can use to bring together data ingestion, data processing, and analytics. A quick intro. I'm a big data architect on the EMR team, so I help our customers make the best use possible of different EMR products like Spark and Presto and Hive, and I also work with Athena, our serverless SQL platform, Glue, our serverless Spark platform, as well as Lake Formation. We'll dig more into those later today. On the screen in front of you, you can see a little website that I built. I use this to generate some of the data that we'll talk about today. So if you feel like helping generate some more web server access logs, browse over to decort.dev, click around a little bit. I've got a couple links on there that might be useful as well, but that's me in a nutshell. So first, let's take a quick intro to data lakes to make sure we're all on the same page there. First, there's more data than people think. Data's growing like crazy, right? The volume, the variety, the velocity of the data continues to escalate. It's growing 10x every 5 years, and the data platforms that we need to build today live for 15 years or more. This is, you might be thinking, Damon, this sounds a little crazy that something I'm building today is going to live for almost 2 decades, but prior to joining AWS, I had a little startup here in Seattle where I built a data ingestion platform, and this was back in 2010. I've since moved on from that, of course, but the data platform that I built there, some parts of it are actually still in production today, which is equally terrifying and amazing. But believe it or not, these platforms that we're building today need to live for a long time, probably longer than we expect them to, and also to scale up much larger than we expect them to as well. On the other side, there's more people accessing the data now as well. So previously, maybe 10, 20 years ago, you might have had some analysts or something like that where they were generating dashboards, maybe on a weekly or a monthly basis. But today, we've got business users that are in there on a daily basis, hourly, generating this data, generating these dashboards from all across the organization, right? You've got sales folks in there, marketing folks in there, product folks that are trying to use this data to make data-driven decisions to make their business better. We've got the data scientists in there as well that are processing huge volumes of data and helping enable the rest of the organization as well. And then the other interesting thing is we've got applications that are accessing this data as well. So they might need sub-second latency. The volume from those applications might be much more intense than standard interactive queries. So all the requirements for making data available are starting to change too. It's not just I need to run a monthly report and I'll kick off the batch job before the end of the day, right? You've got streaming data in real time that you need to account for. On the AWS database and analytics side, I just want to take a quick look at all the different services that we offer in this realm. So as customers are moving these microservice architectures, as they're building these loosely coupled distributed components for their applications, having the right tool for the right job is becoming even more important. And there's a lot of different ways that we can layer these things together. So let's start at the bottom there with the data movement section. This is all about getting your data into the data lake. And that could be bits and bytes of streaming data. That would go through something like Kinesis data streams where you're pushing data in real time. Or if you need to literally ship hard drives across the country because that's faster than transferring it over the network, we have products like Snowball and Snowmobile. So for those two things and everything in between, we have a whole host of solutions on the data movement side. Moving up into the data lake side, S3, of course, is the core of the data lake, so it allows you to collect and store all of that data in one centralized repository in its original format. And then we've got Glue in there as well. And so there's two main components to Glue that I want to talk about. And one is the ETL, the serverless Spark component of Glue. And the other is the data catalog. So the data catalog, if S3 is the core of the data lake, the data catalog is really that crunchy outer layer to it that helps catalog everything inside of both S3 as well as relational databases. It tells you what format the data is in. It tells you what the schema of the data is, and if the data is partitioned, things like that. And it helps enable a whole host of other applications in there as well. Moving a little bit further up the stack, we can talk about databases as well. Depending on what you whether want a relational database. There's options there like Aurora and RDS. If you want key value, there's Dynamo. Depending on what you need to do, whether that's a graph database, a ledger database, all sorts of options there for you to choose from. On the analytics side, a lot of options there as well. EMR, of course, features heavily. So that's our Hadoop framework. You can deploy Spark jobs there, Presto clusters, Hive clusters. And you can spin those clusters up and down at the click of a button, anywhere from one node up to thousands of nodes. So really allows you to scale your data processing in a very, very flexible way. For data warehousing needs, there's of course Redshift. And one of my personal favorites is Athena for serverless SQL over your data in S3. Moving further up to the exciting stuff, we've got our business intelligence and machine learning products, the two that I just want to call out quickly there. QuickSight for visualizing the data, and SageMaker for machine learning purposes. Gives you that Jupyter notebook, a lot of framework for training your models, deploying your models, creating endpoints for that type of stuff. So with all that, we've also got different marketplace solutions on the right-hand side as well. So a whole host of vendors and partners that are building on top of all this data too. A quick definition of a data lake. So we have a lot of customers that are moving to this data lake architecture. So a data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. And I want to call out the unstructured part of that as well. That's one of the big benefits of the data lake, is it allows you to store this unstructured data in there, allow it at a later point in time, depending on what your use case is. The other thing to keep in note is that data lake is an architectural approach more than anything. It's not a product, it's not a tech platform, it's the way that we're storing and processing this data. So you can convert it to whatever format you need to, depending on the specific use case. Today though, what I want to talk about is Damon's data lake. So Damon's data lake is a centralized repository of various quantified self and other personal stats about me, including such amazingly interesting things as my number of open Chrome tabs at any given point in time, my unread email count, which is terrifying, some GitHub repository stats, and more information about myself. So we're going to take all of these concepts and put it into use in order to kind of maintain a data lake of my own various stats. And the tools that we'll use to do that, going back to that previous slide, we'll use Kinesis data streams and data Firehose to get the data into S3. We'll use Glue to catalog that data, keep the schema up to date, and do some processing on it. And then we'll show how you can use Athena to do analytics on that data in S3, as well as EMR in order to do some fun analysis of that data in there. One last quick slide here. What does a data lake look like with AWS Glue? So essentially take that previous slide and pivot it 90 degrees. And this is a typical architecture that we see folks using when they're building data lakes with Glue. So you've got all your data sources on the left-hand side. That could be IoT devices, it could be cameras, it could be mobile devices, all pushing in through the different components that we talked about previously into S3. We've got our Glue crawlers in there that are going into S3, identifying the schema of the data, keeping that schema up to date in the Glue data catalog. And then along the bottom too, you can also see different S3 buckets for different stages of processing. So in most cases, we see folks delivering data into a raw bucket, using Glue to ETL that, process the data and convert it into a staging bucket, and then a finalized kind of processed data bucket where the data is clean, we've deduplicated things, all that kind of fun stuff. The crawlers are there, keeping track of that schema, keeping the Glue data catalog up to date, and then all these services on the right-hand side tie directly into the Glue data catalog. So you can use Athena, Redshift Spectrum, as well as different apps on EMR like Spark, Hive, and Presto to connect into the Glue data catalog and read that data directly from S3. All right, let's talk about some of the fun stuff. Data ingestion. How do we get all this data into S3? So in this section, what I want to talk about, I want to go over a few different of the managed services that we have here at AWS, how they're typically used, and then how I've used them to start getting my data into this data lake. So the first one that we need to talk about is Kinesis data streams. These are elastic, real-time, highly scalable data streams. We essentially create an endpoint and you can start pushing data to that endpoint in real time for other systems to be able to process. You create a shard on your Kinesis data streams, and each shard can process up to 1 megabyte of data per second. And you can scale those shards up or down as much as you like to. So there's a lot of different ways to consume data from the data streams. You can use Kinesis data analytics, which where you can write SQL queries over that data as it's streaming through the system. So you can write window functions or do other types of real-time analysis and push that into different systems. You can use Spark on EMR to process the data in real time that's coming through that Kinesis data streams. You can use custom code on EC2 if you want to, using the standard AWS SDKs if you want. And then one nice integration I really like is the AWS Lambda integration. So you can configure Lambda to connect directly to this data stream Lambda will continue to pull the data stream and process all of that data in real time, scaling up as much as you need to. So very efficient way to push data in real time through Kinesis and process it in whatever way you want. That said, it turns out one of the most common things people are doing with data streams is taking that data and just dumping it out to other systems. So that's where Kinesis Data Firehose comes in. These are delivery streams that can take the data either from an existing Kinesis data stream or from other devices directly or other systems directly and push that into other systems. This is also serverless. You can perform data transforms in there, and it's also near real-time loading to that destination. S3 is a common destination for this, so you can configure Data Firehose to say, take all this data, push it out to S3 in batches, and then you don't really even have to worry about any sort of code or anything like that that's writing the data to S3. Other possible destinations include Redshift for your data warehousing needs, Elasticsearch, as well as third-party vendors like Splunk. So what does this actually look like in an architecture environment? This is a pretty standard setup if you're streaming Kinesis events to S3. So you might have some clients on the left-hand side there. You know, every time we pick up our mobile device, for example, it's probably sending 5 to 10 different events to some device in the cloud, or you can push data in real time to Kinesis streams from laptops or whatnot. You can hook up the Kinesis Data Firehose to that data stream directly, and you can also have a Lambda transformation in there. So each record that's flowing from the data stream to the Data Firehose, you can trigger a Lambda function for, and you can use that to populate data inside of the data stream. You can use that to aggregate other data or things like that. And then what that Data Firehose does is it pushes it all to an S3 bucket. You can specify a prefix up there. So Data Firehose allows you to have a custom prefix there where you can specify different formats. In this case, I'm just using a year, month, day prefix. So for every day, we'll create a new prefix in S3, and every 15 minutes, you can buffer that data in Firehose and dump it out to S3. You can drop that all the way down to every 1 minute, and you can take that 128 megs, and that's variable as well. So you can slide that down so you can dump data in an aggregated fashion there. Now that's great for dumping the raw JSON data or whatever data you're pushing through Kinesis Firehose. But if you are pushing JSON through the Firehose, one thing that it can do is it can automatically convert that to Parquet for you. We'll talk about Parquet a little bit more later on, but it's a columnar format, columnar file format that's optimized for analytics. And so Data Firehose can automatically transform the data for you into Parquet and save that aggregated Parquet data into S3 as well. So this kind of removes one common step of the ETL process, which is taking data in its raw format and just converting it to this optimized columnar format. As you're doing these transformations, Data Firehose can also back up the source data in case you ever need to reprocess that again. So as data is flowing into that bucket, we've got Glue crawlers in there. The crawlers can run over that data, infer the schema, infer the data types, and then populate the Glue data catalog. And then you can use something like Athena to query the data on S3 through the Glue data catalog. This is a fairly common setup. The way that I'm using this is I have a little process on my laptop that's running right now that's pushing a whole bunch of different data through the Kinesis data stream. So this is the sample code. It's just a small batch script, of course. But all this is doing is it's saying, okay, here's a few stats. Here's my unread email count in Outlook. Here are my number of Chrome tabs that I have open right now. And here's the number of terminal tabs that I have open right now. And you can see in the bottom part there that's surrounded in orange. I'm just using the AWS command line client to say AWS Kinesis put record, and I put it on a specific stream. I have the event type, which is Outlook unread or Chrome tabs or what have you, and then the actual data that's pushing through that stream as well. So this just runs every few seconds and just pushes data in real time up to the Kinesis data stream. And then I've configured the Kinesis Firehose to connect into that data stream. And like I mentioned, I'm pushing it out to a specific bucket. I'm using a prefix. In this case, I went all the way down to the hour level. So every hour it's creating a new prefix inside of S3 and dumping it out to there. And then I'm buffering it out every 128 megabytes or 900 seconds, whichever comes first. You can also configure compression in there, which is really nice. And so if we look at what this actually ends up looking like, here's a listing, an old listing of my S3 bucket. And you can see every hour, there's new data being dropped in into that S3 bucket. And you can see there's about 4 different chunks of data per hour. So every 15 minutes, we're dumping out new data. It's pretty tiny data. This is just, like I said, stats streaming from my laptop, so it's nothing too huge. Next, let's talk about some batch processing. So when we talk about that, we want to talk about Glue ETL. Glue is our serverless ETL product. You can do batch operations in there primarily. You can pull in from a number of different data sources, and this is primarily Apache Spark. So you can have Python or Scala code in there. Today we support Spark 2.2 and 2.4 as well. And then Python, we support both Python 2.7 and Python 3. So thankfully, we're in time for the 2020 deadline, so you don't have to worry about that for your Python 3 compatibility needs. One of the other things you can do in Glue is the Python shell. So this is pretty interesting, but you don't really need the power of a distributed framework like Spark. You just need kind of a simple Python script. Maybe you're extracting data from a third-party API, or working with pandas or something like that. You can also spin up a Python shell inside of Glue, and you can think of this like an AWS Lambda function. It just doesn't have that limited runtime requirement, so you can run this as long as you want. So Glue can pull from a whole host of different data sources directly from S3. You can pull directly from other databases as well, whether that's Redshift or RDS or open source databases like MySQL or Postgres. And then it can push it out to other places as well. So Glue ETL is typically reading from these data sources, pushing it out to S3 or another database. And then again, we've got these other systems on the right-hand side that can use the Glue data catalog to go in and analyze this data. So what does this look like in a typical scenario? Let's say we're connecting to a third-party API and dumping that data to S3. This is where you could use the Glue Python shell to go and connect to that third-party API, maybe do incremental exports to an S3 bucket. You can put the crawlers in place to crawl that data as it's flowing into the bucket, so you can keep the schema up to date, and then that would populate the data catalog. If you need to do any transformation of that data, we can spin up Glue ETL jobs. We can spin up those Spark jobs. We can read from the data catalog, transform that data, write it back out to another S3 bucket or a different prefix in the same bucket, and then run those crawlers again over the bucket to keep the schema up to date and the data catalog up to date. And then again, on the right-hand side, we can use different systems like Redshift Spectrum or Amazon Athena to go in and read that data directly from S3. They can read the raw data, they can read the transform data. Really depends on your specific use case and how you've granted access to those data sets. So in my case, I have a bunch of different GitHub repositories that are open source, and I wanted to get some statistics about them. GitHub has a nice little insights tab on GitHub where you can essentially see who's coming to your repositories, where they came from, how many views a repository has had, how many times it's been cloned, things like that. The downside is they only give you data for, I think, 2 weeks. So I wanted to have some historical data so I could keep track of this on an ongoing basis. So I have a small Python shell script where I list out a couple different GitHub repositories, a couple different endpoints, and this just iterates through those, goes out to the GitHub API, pulls the data in from there, and then dumps it out to a prefix in S3. Down at the bottom, you see that save results function down there. All that's doing is taking the JSON data that I just read from the GitHub API, dumping that back out to S3. So fairly straightforward. One nice thing is here, we're using the AWS Secrets Manager as well to get our authorization token, so we can store that securely in Secrets Manager and not have our credentials revealed in the source code as well. All right, next thing. Like I said, we built a little website, decort.dev, to get some website logs into S3. Again, this is a fairly typical approach in terms of website development on AWS, right? We've got a commit hook on my GitHub repository. That triggers AWS code build and code pipeline to go and build the artifacts to their website and push that out to an S3 bucket. Then we've got Amazon CloudFront in front of that caches the data from the bucket, makes it available to other consumers on the internet. And then both S3 and CloudFront have been configured to log server access logs and CloudFront logs to another S3 bucket. Once those logs are in there, we take that in a Glue job, convert them, process them, dump it into a transform data bucket, again, populate the data catalog, and then we can query that with something like Athena. So how is this used specifically for my website? Well, let's take a look at a couple different logs. So first, this is an example of CloudFront logs. You can see we've got two header lines here. One is just the version of the log, and the second is the field names. A little bit different than maybe a standard CSV format, but kind of gives us what we need. A couple things I do want to call out in here. There's a user agent in here, so what type of browsers visiting the website. You can see there's some encoding in there. There's a %2520. So this is actually double URL encoded data that's in this log file. So if we want to make sense of that, we have to do some fun processing with that. You can see there's also dashes in there. So dashes are indicative of empty fields. So we'll have to account for that. And then these logs all get written out to an S3 bucket with an optional prefix, and the actual file name contains a distribution ID from CloudFront, year, month, day format, and then a unique ID to prevent file collisions. S3 server access logs are a little bit different. So a couple things to call out here. One is the date format. S3 has been around for quite some time. So the date format here is this day/3-letter month/year format. It's not quite ISO 8601, but it's something we'll have to deal with. You can see some fields here are in quotes. So that's one single field in there, one single column that's surrounded in quotes. And again, we see the dashes in here, some of which have quotes surrounding them as well. So depending on the field, if it can have spaces or not, the dash will have quotes around them. I know, we all love access or server logs, don't we? So a lot of fun things to deal with here. Again, these logs get dumped into an optional prefix in a bucket. The file name format is a little bit different. In this case, it's year, month, day, hour, minute, second, and then a unique string, again, to prevent file name collisions. So this is a fairly common problem, right? Anybody that is doing any sort of ETL, often it is on different log types. I've seen organizations where they have hundreds of different log types. In most cases, they're unstructured, many different types and formats and compressions. One solution that I've built as one of my first projects at AWS was an open source library that makes it a little bit easier to parse all these different log types. So the code at the bottom of this slide is just 3 lines of code that you would pull into Glue. And you pull in an external library that's linked here, and you essentially say, I want to process S3 access logs, or I want to process CloudFront logs, and the library kind of abstracts a lot of that away. One thing I will note is that in Lake Formation, which we announced last year at reInvent and is generally available now, we make this a lot easier as well. So there's templates or blueprints inside of Lake Formation where you can essentially go in and say, I want to process CloudTrail logs or ALB logs. And you go through and say, pick the log type you want, pick the start time, and then we go and create all of the different templates and crawlers and jobs necessary to go and pull in and convert and process those log types. So if you're doing any sort of ingestion like that today, I urge you to take a look at Lake Formation. This code still lives on for sure. I use it all the time, but Lake Formation is going to make that a lot easier for folks to be able to kind of get up and running. The way that this job gets configured, you've got your source data and your target data. So you specify what bucket your S3 access logs might be, as well as the raw and converted database and table names that you want to use. A couple things to call out here, the extra py files argument. So you can pull in different libraries into your Glue jobs as well. So I've got this custom Athena Glue converter library. I pull that in as part of my, my Glue job configuration. And then down at the bottom, we're also enabling job bookmarks. So job bookmarks are a way to essentially only process new data as it arrives in the S3 bucket. Checkpointing mechanism, essentially. So super useful if you're processing data on an ongoing basis. Each time you run the Glue job, it will only process the new data that has arrived since the last time you ran the job. One thing to call out here, we just recently released functionality for this, where you can actually rewind the job bookmarks. So if you want to go back and reprocess a certain day or reprocess a certain run, you can now do that with the job bookmarks. So pretty awesome functionality there to be able to ETL your data in a scalable fashion. And then we've configured a Glue trigger to say, okay, trigger these jobs every hour, and this is my CloudFront and S3 access jobs. So that's how we've configured our Glue ETL to go out and process our server access logs and convert it to Parquet. So I've mentioned Parquet a few times. Let's talk about that real quick. So it's a column format that's optimized for analytics. Essentially, it takes, if you look at a JSON file, or a CSV file, you've got row by row lines in there. Converting it to Parquet means you're taking it kind of, again, pivoting the data, grouping it by column, and then inside of Parquet, there's also additional metadata on the data that's in there. So we can maintain statistics about the data. For example, how many values are in a given column, what the minimum value or maximum value of that column is. And then we can use that data during processing either to automatically skip some files if we don't need to look in them, or we could do some pre-aggregation as well. So if we're doing a count, for example, if we were doing a count of a CSV or JSON file, we'd have to iterate over every single row, but with Parquet, we can just read the footer of the file and sum up all the counts across the different files. This can be super efficient, especially if you're reading data from S3 using a serverless service like Athena. So I've got just a quick sample here of doing a SQL query inside of Athena over data on S3. So I've got a select count star from our raw S3 access logs, and there's about 7 gigs of data and probably several tens of thousands of files in there as well. So that takes about 81 seconds to run. And what's happening behind the scenes is Athena has to go out to S3, list the objects on S3, pull them into the query engine, G-unzip them, G-deserialize them, count over every single row in that data set. And so, just due to physics alone, that can be challenging, right? On the optimized side, if we've converted it to Parquet, a count star over that same exact data set runs in under 4 seconds, so 22 times faster. And you can see there the data scanned is 0 KB, and that's because we're just going out and we're only reading the footer of all those different files, and the amount of data that we read is so small that it doesn't count towards what we consider the data scanned. So this can really enhance your queries. You can make them faster, it can make them cheaper, and so converting to Parquet is a super common approach that a lot of folks take during that data ingestion process. All right, so we've talked a lot about data ingestion. Let's go on towards data discovery. All right, so far we have JSON traffic stats that are uncompressed. We've got JSON event streams that are compressed. We've got tab delimited service logs. We've got regular expression-based service logs. We've got huge XML files. Oh, that's one thing I forgot to mention. One other way that I'm ingesting data into my data lake is through email, of course. So I've got, I'm taking my Apple Health data from my iPhone and exporting it. And one of the options it gives you when you export it is to just essentially send an email. So we've got some manual processes in here as well. So this is all delivered via shell scripts, JavaScript, and email. And so, in all honesty, this is not much different than the real world. When I've talked to folks about this architecture before, they come up and they're like, "Yep, this is the exact same problems that we're having. Comes from all over the place, all different formats, and sometimes it's really manual efforts to get the data in there as well." So from a data discovery point of view, having all the data cataloged is extremely important, and that's where the Glue data catalog comes into place as well. So the Glue data catalog serves as your centralized metadata repository across relational databases in S3. It's searchable, allows you to classify your data. You can add different business metadata to it as well, and you can manage access to it. If you're using Lake Formation, you can do database, table, and column level access control, and we're extending that to row level access control as well in the future. And then it's Apache Hive Metastore compatible. So if you're running an existing Hive system today, the Glue data catalog can be used as a replacement for that. There's scripts out there on GitHub that allow you to extract data from Hive, import it into Glue, and vice versa as well. So very flexible from that point of view. And then the crawlers, I've talked quite a bit about the crawlers as well. And so these automatically build your data catalog and keep it in sync. They can run over your inbound data, discover new data that's coming in. It can extract the schema definitions from there and keeps all that data up to date inside the data catalog. So there's built-in classifiers for common data formats like CSV and XML and JSON and Parquet, or if there's something you can express with a regular expression, there's Grok expressions as well. So what does a crawler definition actually look like in Damon's data lake? So we've ingested data into a life prefix. This is all my laptop data that's pushing up. We've got some GitHub data that's coming in there for clones and traffic and views. And so what I've done is I've created a crawler with 4 different S3 targets. And then at the bottom, you can see I have an option there that is combine the compatible schemas. So for each target in the S3 targets there, we're going to create one schema for each of those targets. And the Glue crawler is scheduled to run, it looks like 20 minutes after the hour, every hour. So it's going to run over those different prefixes, look at all the data that's in there, identify the schema of it, identify the data types, and keep it all up to date. One thing I just do want to touch on briefly is lake formation. So as we're going through this, you might be thinking to yourself, Damon, that sounds like a lot of work to get all this data into one place. And it indeed is a lot of work to get all this data into one place. With lake formation, we intend to reduce the process of building a data lake from months down to days. So there's automated ingestion that's part of Lake Formation, like I mentioned earlier. It could be existing AWS service logs like CloudTrail or ALB, where now you can go into Lake Formation and just kind of go through a few button clicks and start ingesting that data automatically. We'll build out more blueprints as well as time goes on. And then if you have existing databases, that's also kind of a one-click type thing where you go into Lake Formation and configure that database ingestion. The other big thing in Lake Formation I want to call out is the ability to enforce security policies across multiple services. So with Lake Formation, you have one central place not only to define your data schema and where the data lives, but you can also grant access to those databases and tables inside of Lake Formation. And then all the services that use Lake Formation, like Athena and Redshift Spectrum and EMR, they essentially go to Lake Formation, ask for permission to the data, and then Lake Formation will give you a credential or give the service a credential to that data. And it allows you to have a lot more control over databases and tables inside of your data lake. All right, so we've ingested a bunch of data. We've figured out how to discover all of that data. Let's go ahead and analyze it. My favorite part. So we'll talk about Athena here primarily. Athena is a serverless SQL service that we have at AWS. Allows you to query this data as it exists on S3 without spinning up any resources. So you go into Athena, you run your SQL query, you hit go, and we take care of running that query over the data in S3 and returning the results to you, and you pay on a per query basis. So it's $5 per terabyte scanned, or essentially half a cent per gigabyte scanned. So pretty cheap to go through and scan that data. The way Athena works is it connects out to the Glue data catalog to identify where the data lives on S3, and then it goes out to S3 and queries that data on S3. It's used typically for reporting and analytics. You can take QuickSight, plug it into Athena. Athena has a JDBC driver, so if you have a desktop client or other BI tools or dashboards or whatnot, you can plug those into Athena as well. Machine learning is another common use case for running your SQL queries or processing that big data in a way where you don't have to worry about spinning up those resources. This is a very simple query inside of Athena where we're just selecting from my DL life column. So this is all the data that's being pushed up from my laptop, and you can see it shows all the different events that are in there, the value of that, and any additional metadata that I put in there. And then on the right-hand side of this slide as well, you can see the schema of that DL life table. And this schema is kept automatically up to date by the Glue crawlers. And we'll show a couple more examples of Athena as well in a second. The other thing I want to talk about are Amazon EMR Notebooks in the console. So this is a managed analytics environment based on Jupyter. So inside the EMR console, you can go in there, you can spin up a new Jupyter notebook in a serverless fashion, and you connect to either an existing EMR cluster that somebody's already spun up, or you can spin up your own EMR cluster as well, and then run the code inside the Jupyter notebook, and that notebook gets saved automatically to an S3 bucket as well. So for the purposes of doing our analysis, we want to spin up a notebook and do a little bit of data exploration. So I'm going to jump into the live demo portion of this now. And let's take a quick look at the Glue console first. So inside the Glue console, I've got all my data lake tables in here. We can see my DL life table that I mentioned before. This is pointing to my data lake bucket. If I go and click on that, you can see we're pulling in JSON data there. The crawlers actually maintain a bit of information about the data as it's crawling over them as well. So we can see the number of records in there. We can see the number of files that are in this S3 bucket as well, and the average size of the different keys. And then our schema in here. So fairly straightforward. We've just got string schemas. We've got struct fields that it has automatically pulled out as well. And so then we can flip over to, actually let's go back here to our table listing. And if we want to, we can go and say, okay, go ahead and view that data. And when I click this, it'll pop me over to Athena. And inside of Athena, I can just run a simple query there. Again, the select star from DL Life. And what this is doing is it connects to the Glue data catalog, asks it where the data is, then goes out to S3, lists that data, pulls it in, and then pops it back out into the Athena console here. So you can see some nice stats from earlier this year about my Outlook unread and Chrome tabs and all that kind of fun stuff. You can also do more complex queries. So this one you can see I've got kind of a common table expression, doing some unnesting data, accounting for irregularities in the data, converting it to time stones. So you can do stuff that's a little bit more complex in Athena as well. And you can see that pulls back pretty quickly. Again, this is going out. This is actually scanning all of the data that's in that bucket right now. I didn't really filter by date. But you can see my Outlook unread email count as of earlier this year was pretty high, up at 47. So you can do a lot of stuff inside of here, and we can query our S3 access logs, our CloudFront logs, all sorts of interesting stuff in there. But the other thing I want to show is, all right, let's go ahead and use EMR Notebooks to process that data a little bit. So I'm going to flip over to EMR now. And in EMR, I've got a notebook cluster that I've spun up already inside of EMR. And we can see here that we've got Spark and Livy running. And it's a pretty small cluster, just a single node. We've got a C5 4XL in there. So if we flip over to notebooks, you can see I've got a number of different notebooks in there, and we can spin up and access one of those notebooks, either in Jupyter or Jupyter Hub. And so let's go in here and do a little bit of exploration in that notebook. So pretty easy to spin up. You can either choose an existing cluster or create a new cluster while you're spinning that notebook up. And then when you go in here, you can run all of your queries directly in that notebook. So we'll start with a little bit of data exploration. So to explain a little bit, I've got my Apple Health data that I sent in via email, and that is in XML format. So I just go into the notebook, use Spark to read that data frame out of there. And when this code is running in the EMR notebook, you can actually see the progress of the Spark job. So you can see the different stages that are running, how long it took, and this updates live as that's running as well. And you can see that it starts a Spark application there. So I have this fancy little ring that's called the Motive Ring. It tracks my heart rate throughout the day and also gives me a nice little sleep analysis. So I'll just do a little filtering for my Motive Rings just to see what kind of data is coming out of there. And you can see we've got step count data, heart rate data, and sleep analysis data. Kind of cool. And then what we want to do is we want to take a look at that sleep analysis data just to see what it looks like. So we'll run through that code. And you can see that the Motive tracks both when I'm just in bed and when I'm asleep. So that could be pretty useful. So one of the things I want to take a look at is my heart rate. Getting up there in age, and I need to make sure that I'm staying healthy and making sure my heart rate is in a good place. So let's take a look at some of that Motive data so we can see if we can use that to determine if I'm getting healthy or not. So this is a little bit of my heart rate data. I'm extracting, again, the Motive data, the heart rate stuff, and pulling out the value, and just kind of showing that data frame. And again, you can see how that runs through in Spark in the background, and just quickly shows that in there. So then what I want to pull out is my heart rate when I'm asleep. And so what that looks like, if I look at the Motive data again, I pull in the sleep data from there, and I pull in the start and end date. So you can see when I've started sleeping, when I've woken up. Some of this data, looks like I slept for a minute, so it's kind of tough to have the right data in there sometimes, but we'll figure that out. This was a better night where I slept for, it looks like almost 8 hours, so I was probably a little bit tired that night. And what we want to do next is create some derivative data frames for our sleep and heart rate data. So we need to find our resting heart rate, and in order to do that, we have to figure out when we were sleeping. So pretty standard PySpark SQL stuff here. We're just selecting out a couple different data frames. One for our heart rate, so we're just pulling out our heart rate while we were sleeping. And then kind of combining that with the other Motive data to say when we were asleep and not asleep, right? And so then using that, we can calculate our resting heart rate. So we just pull those two data frames together, filter them out by when I was sleeping, and now you can see, at this point in time, that was what my heart rate was when I was sleeping. So let's do a little bit more analysis of that. And I want to draw some pretty charts. So one of the things that we can do in the EMR notebook is we can create this temporary view. So we take that data frame that we created before, and we create a heart rate testing table or heart rate resting table inside the notebook. Now with the notebooks, we can pull that data out into the local notebook so we can visualize it locally. So using this kind of SQL magic here, we can specify the variable that we want to pull out and the number of results that we want to pull out as well. So you can see that pulls out just kind of this typical table of my resting heart rate throughout the night. If I want to, I can change the, make some pretty charts here. If I scroll down now, you can see that's my resting heart rate throughout April of this year, throughout a number of different data points. Hopefully, I don't know what was going on that night, but I might have to dig into that later. But if I want this chart to be a little bit different, I've done this %SQL magic, and so now I can operate on that data frame in the local notebook as well. And so I use this %% local magic, and I'm going to pull in matplotlib as well as Seaborn for graphing this data. And so I'll just do some basic pandas work on this and pull out what my heart rate is on what the variability is on a day-to-day basis. So you can kind of see, starting in March, my heart rate actually started to decrease a little bit while I was resting. Earlier this year, I was trying to be a little bit more fit, so I was walking more every day, and I was kind of curious if if I was actually getting healthier as a result of that. So it looks like at a glance, my resting heart rate was starting to decrease as I was walking more. But let's reprocess that data, draw a different graph, and again, just some standard stuff in there where we pull this data out and plot it in a different way. And you can see that indeed, the trend of my heart rate from late March all the way through late April does indicate that it was decreasing to some degree. So I think all that walking is actually doing something, which is kind of awesome. Although one thing to note, if this trend continues indefinitely, my heart rate will go to 0. So I definitely need to keep an eye out for that. And then, I figured, okay, I was trying to walk more, but was I actually walking more? And so I wanted to pull out my step count from my health data as well. And I've got the Motive Ring track step count, but also my phone tracked step count, and turns out they tracked it pretty equally. So I'm just going to pull out my my step count from my phone. It works a little bit better. So if we look through that, we can see steps per day in this table. We take our DF walking data frame, filter by the timestamp, and then group it on a daily basis and sum it up. And you can see total number of steps on a day-by-day basis. And again, we'll take that and we'll use this Spark magic to pump it out to a local data frame that we can then graph. And if we take that and just plot a standard line chart using that, we can see that in April, my step count was pretty decent. I got up to 20,000 a couple times, and looks pretty high, but is that normal? Is it not normal? So let's take that. Let's rewind that a little bit. Let's look at it for all of 2019, or at least the first quarter of 2019. And you can see, pretty lethargic through the first couple months there. I wasn't getting much more than 10,000 steps a day, but it's all of a sudden in April, you can see my, I'm getting a lot more steps in. So definitely good for me, definitely good for my body. And that's a lot different than even the previous 2 years of data that I have. You can see way back in 2018, the first quarter there, I was barely doing any walking. So, something I need to work on. So let's flip back to the presentation, and that was how we could use that data inside of the data lake in order to answer some questions about myself. I've got a few other charts here just to go over. We talked about most of them, but am I getting healthier? I am, or at least I was, so hopefully we can continue that trend. And we looked at the step count in April and then January through April to see those changes there. We have some other ways to look at this data inside of the data lake as well. So these charts were generated inside an EMR notebook. This next chart, I ran the query in Athena, then downloaded the CSV from Athena and just popped it open inside of Excel. And so the question of, am I terrible at email, is most definitely yes. The orange line is unread emails. And you can see I had almost 70 unread emails, kind of got frustrated with that, and then churned through a whole bunch of those. And as the after that line went down, you can see the blue line goes up. That's my number of Chrome tabs. So after I churned through my email, I got back to work, and Chrome tabs started opening a bunch of Chrome tabs again. I mentioned I'm also tracking data from GitHub, and so I have an Athena query where I can look at that data from GitHub, and these queries are all on my Damon's Data Lake repository in GitHub. This is all available for you to take a look at. So GitHub, I can take a look at views per repo per day, and this is a SQL query that goes out to that DL views table, aggregates a whole bunch of data, and pulls it into Athena. So I can run this inside of Athena, and that'll go out and pull some data about the repositories that I work with on a daily basis. And then, like I mentioned, you can connect QuickSight into Athena as well. So you can plug the SQL query into QuickSight, and here's the different repositories and accounts, and I can take that, pull it into QuickSight, and that's what we have in this next tab. This is a QuickSight graph that connects directly to Athena and shows me what projects I should focus on. So this Athena Glue service log project has a decent number of views every day, and so I should probably keep working on that. One of the other pieces of data that I'm pushing up for my laptop is every time I copy and paste something, I track the app that I copied it from and the app that I copied it to. So again, you can see the SQL query up there in the top right. This is kind of fun. You can see that I copy and paste a lot to and from Google Chrome. So this is copying URLs or other things to and from Chrome. But you can also see I copy from Chrome into my terminal app and from my coding app into Chrome and vice versa. So essentially what I'm doing all day is debugging code, copying error messages from my terminal into Google, and helping me resolve issues just like any other developer. Then finally, we can also look at the CloudFront data as well. So these are all the server access logs of people visiting the website. And so I filtered out Mozilla in this case just to see what interesting user agents are visiting my site. And you can see there's a lot of robot user agents coming in there, whether it's Go code, curl commands, or Twitter bots coming in there and going in and checking out the website. So kind of neat to be able to see that info as well. So at the end of the day, what does this all look like? So if you remember the Glue data lake slide from before, this is the architecture that I used for my own personal data lake. So we can see our sources on the left-hand side. This is my laptop, my Apple Health data flowing through me, emailing it in, and uploading it to a bucket. The Glue Python shell pulling from the GitHub API, CloudFront logs going directly to that raw bucket. And then we've got Glue in the middle where the crawlers are crawling over that raw bucket and populating the Glue data catalog. We've got a Glue job in there that's going and converting data and processing it into a process bucket. And again, the crawlers are picking up that schema and keeping the Glue data catalog up to date. And then we've got Athena and EMR Notebooks up there that are reading the data through the Glue data catalog and directly from S3. The code for all of this, I should mention, is up on that repository linked in the slide. The other thing I want to mention about this too is this entire architecture can be created from the GUI. I didn't have to write any code or start up any servers to do this. Kinesis data streams, the Glue Python shell, all this stuff, I configured this all in the GUI and just kind of tied it all together. So really easy to get up and running, fully managed, fully serverless, and makes it so the only thing you have to worry about is converting funky date formats on a daily basis, which we all have to do. All right, and so that's it. Thank you, everybody, for coming today. Really appreciate you taking the time to take a look at this. Feel free to take a look at the GitHub repository. And if you're going to be at reInvent this year, we have a number of great sessions, both on the EMR and Athena side as well at reInvent. So one I'll call out is the Spark Performance talk. We've done a lot of work this year enhancing Spark Performance on EMR. So definitely tune into that one to go listen to one of our principal engineers talk about that. We've got a couple other sessions about what's new and deep dive with Athena as well. So if you're at reInvent, by all means, go take a look at those. If you're viewing this afterwards, all those sessions are available online as well. So go ahead and check out the videos for those. Again, thank you so much, and let's move to Q&A.